but people may also be buying a radio that's an HF, VHF, UHF combo. So either one of those we're going to talk about today. There's 5 basic components to an HF station. The HF transceiver itself, a power supply, usually 12 volts to run the radio, an antenna or more than one antenna, some feed line to get to the antenna, and depending on your mode of operation, either a microphone or CW key. Here's a picture of a typical radio installation. We have a Yaesu FT991A here, a switching power supply, a connection here with our power cable, our antenna coming in, and the microphone. Some other extras that you may have, an antenna tuner, and some of these may be built into the radio, so you might have a built-in antenna tuner, a sound card interface for using sound card modes such as FT8 and FT4, a CW keyer, a voice keyer, sometimes referred to as CW memories or voice memories, CAT computer software to be able to interface the radio to your computer. If you have a rotator control box for that. If you have more than one antenna, you may have a simple coax switch, an AB switch. And if you have multiple accessories in the shack, in addition to powering the radio, you might need to have a distribution system for your DC. Example of probably the simplest and one of the first antennas that many amateur radio operators use is an HF dipole. Very inexpensive to build. The biggest cost, of course, is the feed line, the coax, but the wire and the insulators can be anything. Even little pieces of plastic could be used here. And this is the basic formulas for a dipole antenna. Where to put your radio is one of the questions that many of us face when we first get into amateur radio. And amateur radio operators affectionately call their radio location their shack. It's been used for many years, refers to where your radio and other equipment is installed. Shacks can be inside the house, garage, outside shed, basement, etc. Spare rooms, dens, anywhere. Some of the considerations for locating your shack: noise and privacy, both yours and those around you. My wife loves when I do CW contests because she doesn't hear anything, but when I'm doing a voice contest, she can hear me yelling. So it's good that the shack is on the other side of the house from the bedrooms. We need sufficient power, AC service. Now, it's not a problem for a simple 100-watt station. Anything that you have electrical wire-wise in your house will be just fine for that. But if you start using a power amp, you may require 220 or a higher amperage surface. You need a desk or countertop for the equipment. And the whole idea of furnishing the equipment, the furniture for the shack, is you want to make it functional and comfortable. So you could put your shack on a kitchen counter, but there'd be no place to put your legs underneath. So keep that in consideration. Also, safety is important. Isolation from infants, children, or pets. Access to outside antennas and grounding is helpful, so having it on an outside wall of the house is very helpful. And personal comfort, heat, humidity, dampness, etc. can be important. If space is limited, consider a rapid deployment type go box. This is a go box you can pick up, set down, open the front, and be able to immediately start operating. And that was my first shack when I started out. I lived in an apartment and I made a simple wooden box to surround my radio, power supply, antenna tuner. I could pick it up by the handle on top, set it on the desk, operate. When I was done, put it back in the closet. And I have a whole presentation on rapid deployment type of go boxes and amateur radio grab and go boxes. So you can click on these links. Anytime you see the little icon, that means that there's a link for resources, or the italicized font also means that you can click on that link. Closing storage can allow for safe, secure storage of equipment when not in use. If it's in a high traffic area and you want to keep other people out of it, something like that can be helpful. I mentioned earlier, and I'll mention it again, a comfortable chair is very important. This allows you to spend much more time operating. Butt in seat time is very important, especially if you want a contest. And if the seat is not comfortable, it's hard to keep the butt in it. So you want to have comfortable chair. You might want a separate workshop area for repair, soldering, kit building, etc. One of the conditions of moving my shack into the main portion of the house was I promised my wife that I would keep a separate area in the basement for all the repairs. So I actually have an operating shack, and then I have my repair and kit building area in the basement. So the two are separate areas. You can use your wall space for a number of accessories, including a 24-hour UTC clock, maps, charts, displaying QSL cards, and awards. And you're going to need plenty of space to display your awards if you really get into this. Storage for accessories, supplies, books, etc. can be helpful. And access to home internet has become very important for radio. When I first started out, it was not a consideration 40 years ago. But now I utilize online spotting, reverse beacon network, posting to real-time online contest logs, and a variety of online resources. So my computers became an integral part of my Radio Shack. Let's talk a little bit about some of the components we mentioned earlier. The first one is the power supply. There's two different main types of power supplies, referred to as a linear, which uses a transformer to step down voltage, and that's usually the heavy one. When you pick it up, it's going to have some heft to it. The newer type is called a switching. It does not use a transformer, so they're usually much lighter, sometimes more inexpensive, and they can be very good choices, but some switching power supplies are notorious for creating noise, RF noise, which may cause you some problems. So I have a whole presentation here that someone else put together on linears versus switching power supplies, which is best, and you can go off and read that after today. They may not have warned you when you joined today that there'd be plenty of homework for you. The output of the power supply is typically 12 volts, but it's actually nominally about 13.8 volts. So we call it a 12 volt supply, but most of the time it's ran at about 13.8 volts. Amperage, a typical 100 watt HF radio requires anywhere from 18 to 25 amps during transmission. I would suggest that you make sure your power supply is sufficient to be able to do that, and especially if you want to be able to run multiple radios. So let's say you have an HF radio and you also want to run a VHF mobile in the shack. So you might want to think about a power supply with a little more amperage. Definitely too much amperage is not a problem. The power wiring is very important. When you're running DC cables, if the cable's too small, your drop in power voltage can be very significant, and that can cause some problems with some radios. So you want to maintain a large diameter wire, and you want to use good connectors. I use Anderson power poles for all my connections in my shack. I've been doing it for over 35 years now. Years ago, people said, what is that strange connector? Now everyone recognizes them because it's became sort of a amateur radio standard. Make sure when you wire them, you put the connectors on in the acceptable fashion. This particular one is actually being shown backward here, unfortunately, color-wise. I have 3 videos here on putting on Anderson power poles. If you have multiple devices in the shack, you can hook up one power supply to a power distribution box and then distribute your power to a variety of accessories. So in this case, it's a little DC power distribution box. Here's one from MFJ that has an on-off switch and a voltage indicator on it. You would connect your power into it, and then you would run each of your accessories, and each one is individually fused. Probably the most important part of the Radio Shack is something that's outside, and that's our antenna. There's a number of antenna varieties out there, everything from wire antennas to antennas made from the feed line itself to pieces of aluminum such as verticals or beam antennas, and even hybrid antennas that use wire and supports to mimic aluminum. We can also have loops, and I'll go through some of the different antenna types a little bit more, but that's not where our main focus is today. So I've put together a whole presentation. This was originally designed for use a couple years ago when everyone was doing field day on their own instead of with the club.
It's just ridiculous. Then we'll go back to community thesis. Here's what I find interesting. You know, Axios, everybody FT, last night on MSNC, he's crazy. He sounds crazy when he talks.
Chris, could you please mute?
In blocks of taking over.
Yes. Sorry.
Thank you. So I put this together for people that were just starting out and really hadn't used antennas a lot. And originally it was for portable antennas, but I've expanded it beyond that. So when you click on this link, it'll take you out to that presentation. And the presentation talks about the pros and cons of different types of antennas. And then it goes through and gives resources for both commercial and homebrew versions of each of these different types of antennas. So there's a whole variety here of verticals, beams, dipoles, wires, end-fed, stealth, 160 meters, mobile, VHF, UHF, even a little chart from the villages in Florida talking about the stealth ability of various antennas. So again, this is available by clicking on the link in the presentation that says tiny.cc portable antennas. This is my antenna farm. I'm lucky enough to be able to squeeze a tower onto my property. As you notice, I don't have a lot of room for it, but I do have a 50-foot crank-up tower here with a hazer unit on it. And I have a three-element beam on there. It's for multiple bands, 20 through 6 meters. I also have 2 wire antennas coming off, an 80-meter sloper pointing to the northeast and a 60-foot loaded coil 160-meter sloper pointing to the southwest. I also have a 43-foot vertical DX engineering antenna that you can't see because of the trees here. By the way, especially if you're operating portable, Google Maps can be your friends on picking out what type of antenna you're going to be using. Each year, my wife and I travel for field day, and we're going to a new location I've never been to before, and I got to figure out what kind of antennas I'm going to put up and what kind of space I have and how I'm going to put them up. So this was our field day location 2 years ago. Actually last year, I'm sorry, in Triadelphia, West Virginia, and I was able to see ahead of time that I'd be able to go from the corner of the roof, 67 foot, and be able to fit in my end-fed antenna to this tree here. I actually ended up putting it on one of these trees along here, but this gave me an idea of what I was going to be able to do before I actually got there. You need to feed your antenna, and there's a number of different ways to feed it. The most common way we feed most antennas is with coaxial cable. So when you're planning your budget for purchasing your radio for your HF operation, remember there's going to be some cost for not only the radio and the antenna, but also some cost for feed line. And spend some money and buy some quality coax. Buying the wrong coax can mean that you can be losing half of your power before it ever gets to the antenna. Don't ignore open-fed line. It can be very inexpensive, much more reasonable cost and low SWR and low loss in it. So ladder line or 450 or 600 ohm open line can be very helpful for some setups. When you're talking about coax, there's multiple diameters, insulated materials, impedance, loss, frequency, etc. Typically for amateur radio use, we limit ourselves to 50 ohm cable as opposed to cable television computers which use 75. So if you're buying that chunk of random cable at the Hamfest this afternoon, make sure it's 50 ohm if you want to use it around your shack. You can get by with 75, but you're going to be running into some issues. The quality varies by the manufacturer, the time that the coax has been in use, its exposure to the elements, and mishandling. Overpower is one bad thing about it. So if you're running too much power through coax at a mismatched SWR, you can actually arc over and damage it. Kinking can also damage it. This is a chart showing typical losses for coax, and you'll notice as we go up in frequency, the losses always tend to go up. So if we're using our coax at 160 meters around 1 megahertz, we can get by with almost any of these cables. But if we're moving up to 6 meters, you notice that these first 3 become totally unacceptable because of the losses. And really, we need to get down to this area before we start finding a suitable replacement. So again, the frequency you're using it at can help determine which coax to use. I pretty much use LMR 400 for most of my higher band stuff, and I do have some RG8X which I'm using to feed my 80 and 160 meter antennas because of the lower cost. The connectors that are used are typically a PL259. It's called an UHF antenna connector, but that's totally a misnomer because it's typically not used above VHF. It's used by the majority of HF manufacturers on the back of the radios, although many QRP or portable radios use BNC connectors. So you might have a BNC on the back of your radio. And actually the socket is not a PL259. The corresponding socket is an SO239. A BNC connector is quite often used for portable radios, QRP radios, and test equipment. SMAs are very common on newer HTs, UHF, microwaves, and weak signal work. End connectors are a waterproof connector typically used on UHF and above, microwaves, weak signal work. A lot of times on satellite and EME, end connectors are used. The type of connector that's used for cable TV, video, and receive-only amateur radio antennas is the F type of connectors, and they're not really used for any type of transmission for the most part. Installation varies by the type of conductor. Some are solder and some are crimp. I have 2 videos here, one on installing different types of connectors, and another one on soldering on connectors. So these two videos can be very helpful. By the way, there's no shame in buying coax with pre-installed connectors, but make sure the cables and the connectors are high quality. And if you're buying them from a reputable dealer, they will not only assemble the cables, but they will test them with very important test equipment that's beyond the use of most home shacks, so you can be assured that your cable will be good. But do remember, if the connectors are already on, you need a bigger hole to get it into the shack. And that's one of the most common things I hear from technicians when they're first starting out. New hams always say, well, I got a radio in the shack, that's no problem. I got an antenna outside, that's no problem. But how do I get the coax into the house? In my first house, it was a rental apartment, so what I used is the dryer vent to be able to get into the shack, because I had no other way. I couldn't make a hole in the wall to do it. If you are using something like a 45-degree angled PVC pipe, a dryer vent, or anything along those lines, remember that you need to pest proof it. And to do that, make sure you put in I usually put a rag in first, and then I follow that with some screen door material. The metal type is preferable, and that'll deter pets from chewing their way in. I had a bird make a nest in one of mine one time. You can also use these type of panels. This is one from MFJ that fits in the window. You can push up your window, it mounts on a piece of wood, and it has pass-throughs for it. And here's a very professional looking box that has connectors and everything mounted, and then going into the house with a cover that covers it for safety, and grommets at the bottom to keep out insects and other critters. Grounding is very important. There's two types of grounding, though. You need to be aware that the two types of grounding are very different. Electrical grounding is for electrical service safety. You must follow local regulations in all construction. This has to do with your AC sockets and things of that nature. RF grounding, on the other hand, is used to prevent interference, stray RF in the shack, etc. It's not the same as electrical. The distances between equipment and ground are important, because when you're doing RF grounding, if the distance is too long, you've basically created an antenna to just propagate that RF around the shack also. N0AX, Ward Silver has a great book and a video on grounding and bonding. Now, there are some alternative views on some of the station grounding, and Steve Katz is well known for his very vocal opinions on that. So I have Steve's other opinion here on station grounding, and it's very interesting reading. So I suggest you read both Ward's information and Steve's information, two well-respected hams in their fields. What else will you need? Well, typically you'll need a microphone if you're going to operate phone. It may or may not be included with the radio. You might want a cat interface cable, a computer interface cable. Newer radios typically use simple USB A/B cables, so you don't have to worry about that. But if you have an older radio, it might require an RS-232 cable and an adapter to go to common newer computers. And it might even have proprietary connections or an interface box required to go to the computer. Whenever you're dealing with RS-232 to USB adapter cables, it's always important to avoid cheap counterfeit cables. I would avoid prolific drivers and always stick with FTDI chips. If you don't know what that means, when you're searching for them, just make sure that it says it's an FTDI USB adapter. Some other things you might want are headphones. I use headphones whenever I'm operating, not only for the convenience of my other family members of not hearing me, but it lets me focus much more, especially when I'm operating CW. And as a matter of fact, I have two separate sets of headphones. I have one pair that I prefer to listen to CW on, and then I have another pair that I prefer to listen to phone on. So I actually change headphones depending on which mode I'm operating. For hands-free operation, you can use a headset with an attached microphone and then use a push-to-talk switch on the floor or a push-button switch with your hand. You can also operate Vox, voice-activated operation, if your radio supports it, but remember that outside sounds in the shack may trigger the Vox accidentally. You will need some accessories for coax. If you start adding accessories such as an external SWR meter or power meter, you'll need one cable to go from the radio to the meter before it connects to the coax. So coax jumpers are very important. And if you have more than one antenna, you might want an A/B switch. Also, if you're dealing with different connectors on your radio versus what's on the cable, you might need some adapters, UHF to BNC, BNC to SMA, etc. A borrow connector allows you to join two lengths of cable together, both with two PL259s, an AB switch if you have more than one antenna or feed line. You'll need some tools for station installation and maintenance, and I won't go into great detail on that for this presentation. Let's talk a little bit about computers in the Radio Shack. Computers can be used for radio control. They can be used to operate digital modes such as FT8, FT4, RTTY, PSK, etc. They can also be used for logging your contacts. I keep all my contacts in electronic log. And if you contest, you might want a contesting software for keeping track of QSLs, printing out QSLs, etc. You can also find stations that are available to work by using spotting clusters or the reverse beacon network. And if your radio has a band scope on it, you may be able to display it much larger on a computer screen. So you might use your computer as a secondary band scope display. So computer to radio interfacing is often referred to as CAT. It can be used for controlling the radio. It can also be used for programming memories, updating firmware, especially on VHF, UHF radios where you might not be using computer control. You might use the interfacing cable to be able to program the memories. If you're operating the digital modes, such as FT8, FT4, audio in and audio out from the radio can be accomplished with this radio interfacing. Now, if the radio has a built-in sound card, you can do that just by hooking up a USB cable. If it does not, you might need to use an interface device such as a sound blaster or other device. You can also use your computer control for turning your rotator for your beam. Here's an example of the difference between interfacing two radios. The orange radio over here does not have a built-in sound card interface. So I can use the CAT control to control the radio with the computer, but I need a separate interface, sound interface, to be able to interface sound from the radio to the computer. If the radio has a built-in sound card, which most of the newer radios have, one simple USB cable can be used to handle both CAT control and sound card integration. I keep saying the word CAT, and CAT stands for Computer Aided Transceiver. It allows you to control the frequency and mode of your radio using a computer program, a logging program, contesting program, etc. CAT also allows you to read the frequency and mode from your rig and import it into the computer program. So when I'm logging using my logging software, I never need to put in the frequency that I'm operating on because my software automatically reads it from my radio. And that's one thing I find very important, because back in the olden days, I'd always forget to change the frequency in my log when I would change the frequency on my radio. But with interfacing, it's not a problem. Earlier CAT interfaces used either RS-232 or TTL logic. If TTL is used, a level converter was usually necessary, and the earlier Icoms required a TTL interface unit. Some early systems used proprietary interfaces and/or connectors. Nowadays, most of the time, all you would need would be a simple USB cable. When you're buying your USB cables, I suggest you purchase the ones with the ferrite noise suppression on them. They're not that much more expensive. And also go with quality cables. For a sound card interface, for details on using that, I have a whole presentation on using FT8 and FT4, and you can also use it for other purposes. These are some examples of sound card interfaces: the Tigertronic Signal Link, which is displayed here, the DigiRig, which is a very inexpensive, tiny little interface. MFJ has a whole series of 1204s, and there's some other ones out there. Some optional accessories you might want for your shack might include CW paddles, or a key if you want to operate CW, an external CW keyer if the radio does not have a built-in keyer, or if you want additional features. I like using an external box even though my radio has a built-in keyer, because I have a 6 memory box with a easy to change speed control on the front of it. I'm using a Ham Gadgets Master Keyer MK1. You might also want an external speaker, although I go with the headphones most of the time. Having an external SWR and power meter can be very helpful. The one your radio only has a limited display to it. It is not especially accurate in many cases. So having an external SWR power meter is a great way to keep track of the conditions on your feed line and the power going out. Now, it's great to come to sessions like this today, but when it comes time to actually do the work in the shack, it's great if you have a mentor to help you out. So it's very important that you find a mentor. One of the things we really should do is when you get that license, we almost need to assign you a mentor. So look for mentors out there. If you haven't already found a mentor, I suggest you find one. Now, these days, there's a variety of ways you can find a mentor. The first place you might want to look is the local club that you've just joined or that help provide your technician licensing class. Lots of old timers are more than happy to help newcomers, and many clubs have formal mentoring programs. If you want to find a club in your area, here's 2 resources to do that. Nowadays, you might also find your mentor online. There's lots of websites and mailing lists that are geared towards helping people become better amateur radio operators. One common fallacy is that you can have only one mentor. In fact, many hams have multiple mentors both in person and online. So that completes the presentation. We're going to have some time for some questions, and I'm going to do some other show and tell. But before we get to that, again, to access all the resources in today's presentation, tiny.cc/SUHF is the link. And I'll put that in the chat when I get a second here. Also, this is my contact information, khzt@awrl.net, or my website at k8zt.com. I also have been doing a number of presentations. My goal since the start of the pandemic is to present all states. I'm at about 35 states in 4 countries. You can get to all my presentations at tiny.cc/k8zt-p. You can see all the slideshows. Many of them have recorded videos along with them or additional resources to go along with them. So I will go ahead now and start taking questions, and I will also show a couple other things on the screen. So let me go ahead and stop my share for right now. Please feel free to raise your hand or to type things in the chat, and I'll try and keep track of it there. I'm going to put the link to today's presentation in the chat. Now I'll go ahead and take the first question.
Yeah, I think I've got you as co-host, so you can unmute folks. But if you have a question for Anthony, please ask it. Anybody in the room have a question? Okay, we do have a question in the room, Anthony. Can you hear me okay?
Right. Yes.
But I'm listening to people on like 75 and 80 meters. Some of them just have like sound quality, just like broadcast quality sound. What are they doing that's so special that they can get such a good sound to their transmission?
Well, I'm going to tell you something you're not going to want to hear. Don't do it. Don't waste it. If you want to do that, get a job at a local commercial station. The whole idea is to communicate, and not to say anything bad about it. It is a facet of the hobby, but you give up some capability of making contacts by trying for high fidelity. So you don't really want a wide signal because that hampers other people on the band. And I would concentrate on making sure your signal is readable and clear, but not worry so much about the audio quality being studio quality. It is amateur radio. It is not commercial broadcast. So I'm not the person to talk to on that. I know there are people that follow that, but I'm not the person to ask that particular question for.
Anybody else? Yep, hang on.
What would you recommend for somebody who's just getting into the hobby as their first radio?
Yes, I anticipated that question, so I have on the screen right now, and give me a thumbs up, someone, if you can see the spreadsheet.
Thumbs up.
Okay, very good. So this is one of my presentations on buying amateur radio equipment, and I go into detail in the slideshow on different aspects of it, but then I have an accompanying spreadsheet that goes along with it, and on the bottom you'll see that there's tabs. The first tab is the HF rig matrix. This matrix shows radios that are currently available or have been just discontinued in the last couple of years. It goes through different categories on each one, talking about what type of radio it is, what bands they cover, whether they have CAD interface, what type it is, built-in sound card interface, CW decode capability, and some prices. You can go through this list and take a look at these and get some ideas on what you're interested in. If you're just starting out, in a lot of cases, I suggest, if you have the money, to think about an HF radio that also has VHF and UHF, if that's your interest. If you're just interested in HF, don't go that route. But if you want to be able to do both, you can look at this chart and you can see that the Icom 705, which is a QRP radio, so it's low power. So I'm going to say that maybe that's not the route you want to go. But if you look down the list, the Icom 7100 has VHF and UHF on it also, has a built-in sound card interface. So it'll be very easy to use the FT8, FT4 type of modes very quickly. The the Yaesu 991A, again, a radio that has HF, VHF, UHF capabilities, 100-watt radio, built-in sound card interface, an antenna tuner built into it, is another good choice, I think, for people just starting out if you're looking at new equipment. There's a number of other radios that are available in the used market, but again, if you're buying used equipment, I would suggest you have a mentor that can help you directly with these types of things. I wouldn't suggest to someone just starting out that they jump into the used market if they're not real familiar with things. Now, if you're looking at just an HF radio and your cost is a problem, the Yaesu 891 is designed as a mobile radio, but it can easily be used in the shack. It's under $700. It has HF and 6 meters. It does not have a built-in sound card interface. You would need to add a sound card interface if you want to use it with FT8 and FT4 on it. But if you just want to get on the air on phone or CW, the FT891 can be a good choice at a very low cost. So there's a number of radios like that. By the way, this chart does not have any over $2,000 radios on it. I purposely left those out because I thought most people starting out, that would not be their main concern. On the second tab on the bottom on HF, I not only have the current radios, but I have most of the radios over the last 25 plus years, including the discontinued models with links to information on them. I also have tabs on the bottom for mobile VHF, UHF, HTs, etc. I have a tab on the bottom for manufacturers, so you can go to the websites of the manufacturers for more information. And I have another link with ham radio resellers and the particular models they carry, so that you can get an idea of some of the prices on these by going to their websites. Did that answer your question? And I actually have a second follow-up for you. What type of interest do you have?
I have no idea.
Okay, that's good.
Oh, probably everything.
Okay, so I think you probably, if you have the money available, I would consider going with one of the radios that have HF, VHF, and UHF built in.
Very good. I know some of the DMR is popular nowadays. I didn't see any of that on that particular list. I know this is particular for HF, but
yes, the DMR is a VHF UHF thing.
Yep.
Now the Icom 7100 does have Icom's version, which is called D-Star. It's similar to the DMR, and it's built into the Icom 7100. So that is a consideration if you're interested in D-Star. That particular radio does have D-Star built in. If you're interested in DMR, though, I would consider going to a VHF, UHF radio that is a DMR radio. There's nothing that says you can't buy an HF radio and buy a separate VHF, UHF radio. So don't feel that you have to go that route. I'm just suggesting that if you're starting out, that might be one thing you want to consider.
yeah, half the people I talk to, Ron, the host here, half the people I talk to on HF end up, the newer ones, having 7300s.
The 7300 is a very good radio. VHF, it's a HF 6 meter only, has a very nice display on the front of it, and that's what a lot of the people fall in love with, is this display on the front, and that's a very good radio.
Any other questions in the room? Hang on, got another.
Hi. Yeah. I have some trees in the yard, and I have a wire antenna, but I have no intention of putting up like a tower. Nothing so grandiose. But can you recommend maybe maybe a nice telescoping mast that isn't too wimpy yet, not too hefty?
Well, let me talk a little bit about when you're using a vertical antenna. Well, first of all, when you're using a mast, you can use it in two ways. You can use it as a vertical antenna by having a vertical element on it, or you can use it to be a support in a horizontal type of antenna, a dipole or inverted V. But whenever you're talking about using a vertical antenna, in most cases, it's going to be beneficial, if not necessary, absolutely necessary, to have guy wire, radials, a counterpoise. So don't forget about that aspect when you're considering an antenna. A lot of people say, well, if I buy this vertical, that means I only need this one small spot to be able to do it. No, you're going to have to invest some time and effort into putting down a decent ground system to get good results from a vertical. That's why I suggest in a lot of cases going with a dipole or an end-fed horizontal antenna sometimes is an easier route than putting in a vertical. So if you have one support possibly from your house and another support out in the yard, whether it's either a temporary push-up mast, a mast you make yourself with PVC pipe is what I had in my backyard for a number of years. I telescoped a few pieces of different lengths of PVC together and had a 24-foot mast in the back, and I used that to run one end of my end-fed antenna from the house. So that's one route to go. You're really going to need some look at your property that you're on, make some considerations of what you can do antenna-wise. Antennas are really an area that requires a lot of thought. So if you can find someone that can help you out on that, that's a great way to go. If you are looking at a vertical, remember you are going to spend some time with the ground plane. Now, I just was working with a gentleman who had a limited space to put up an antenna, but he happened to have a chain link fence that ran all around his yard. So we were able to tie together his chain link fence, a couple radios in his yard, and put a vertical on there and still get a pretty decent performance without a lot of property to do it on.
Awesome. And there's a question in the chat that says, what effect might a 5G tower near your house have on a handheld radio?
I don't think you're going to see any effect at all. It should be very minimal. It's designed, there should not be interference outside of the band that it's operating on. I've not noticed any problem with that. Now, if you're going up next to a cellular tower, it might be a different story. And some people that do SOTA, which is summits on the air, have discovered that, you know, some of the high spots because of the commercial antennas on top of them can be problematic. But I don't think you're going to have a problem with your area.
Yeah, that's a pretty high frequency there.
Yes.
Anybody else? Got a couple more.
Hi, I was wondering, what do you think about random wire antennas with an external antenna, tuner?
I'm a firm believer in those. I use them quite a bit. Actually, I use a random length antenna when I'm operating portable with my Elecraft KX2. It has a very good built-in antenna tuner, but also having a good external antenna tuner means that you can easily tune something like that. Now, I'm operating 5 watts QRP, so I don't have to worry too much about with end-fed RF getting back into the shack. But that is one consideration that you sometimes run into with an end-fed. But if you're using a quality antenna tuner, now, even when you look at those antenna tuners on that chart, let me bring up the chart real quick because I want to point out something on that chart for you. These aren't exact figures, but when you look at the built-in antenna tuners, you'll see some of them described as 3-to-1 and some are described as 10-to-1. It makes a big difference. Some of these antenna tuners in the radios, built-in antenna tuners, aren't able to tune any antenna. They're only good for antennas that are fairly resonant on their own. Other ones are much more effective, and if it's not, then the purchase of an external antenna tuner can take care of that problem. But be aware that some of the built-in antenna tuners, like the one in the 7300, aren't necessarily very wide-range antenna tuners. Next question?
Yeah, I have a Baofeng as a cheap starter radio. What is your opinion on those?
It's a cheap starter radio. If it's getting you on the air, it's great. I have one here in the shack. I don't think there's anything wrong with them, but if it's getting you on the air, that's the important thing. But what I want to stress to you is that amateur radio is not just local repeaters. So I have a whole presentation I've done, and it's in the list there. It's called Technicians Beyond the Local Repeater, talking about some other activities you might want to consider doing with your Baofeng. You know, your Baofeng could be used to do simplex contacts. It could also even be used to do satellite. Low Earth orbit FM satellites can be used with a simple dual band radio and a small antenna that can be pointed towards a satellite. So take a look at my presentation, Technicians Beyond Life Beyond the Local Repeater, for some more ideas. Another thing you can do to make your Baofeng even more helpful, more useful, is to get an extended antenna for it. And in my presentation on portable operations, I talk a little bit about extending the range of your HT. Something as simple as what's called a tiger tail. It's a short 19-inch extra wire that you put on the base of the antenna. Can help make the radio improve its range a little bit. Also, an extendable antenna might be helpful, or even a small small beam that you could point in the field and operate portable. So think about some other aspects to maximize your ability to get out.
And that's the first part of an answer to a question that's in the chat here. What is a good portable radio for a beginner?
Well, the thing about that is, first of all, what bands do you want to operate? And then the second question is, how much power do you want to carry into the field with you? So when we're talking about portable, if it's portable in an automobile, you have the battery system of the automobile. But if you're talking portable where you want to go out and hike out into the wilderness and use it, you're going to have to be able to carry your power in with you. And once you start carrying your power in with you, it becomes quite difficult to operate a full 100-watt radio because of the required amperage to operate it. So in that case, you might want to think about one of the portable units such as the Icom 705, which is a 5-watt radio, has a built-in battery supply on it, and it's got all the coverage of different bands. It's a little bit expensive. It's about $1,300. If you're not interested in operating HF, if you're only interested in operating VHF, UHF, then you can get by for a lot less. But if you want to have full capability, something like the Icom 705 could be helpful. The Yaesu FT818 is again a portable radio that can use internal batteries or a battery that you might carry with you, coverage on all the bands. If you want really good performance on HF, but not worried about VHF, UHF, the Elecraft KX2 and the Elecraft KX3. The KX2 covers 80 through 10 meters. The KX3 covers 160 through 6 meters. These radios are a little bit expensive, but they're really good high performance radios, but they are 5-watt radios. So they're QRP radios. Anytime you see the Q on the chart, that's going to refer to a QRP radio, less than 10 watts of power. Now, I operate in the field quite often with my KX2, a 27-foot random length antenna, a push-up fishing pole, and I've worked all over the place. But again, you're going to need to learn the techniques to be successful. I have a whole slideshow on operating techniques, and you have to be patient when you're using 5 watts. It's not going to be quite the same. But if you go to a park and set up a POTO operation, something like the KX2 can be great. The 818, even the new radios from Xiegu, the Xiegu X6100 is a portable radio that has a built-in battery. It's fairly new. They're still working out a few bugs in the firmware, but I have one of these, and I think the radio performs pretty well, but there are a few things being worked out. Not real expensive, not as great a performance probably as the Elecraft KX2, but a good starter radio for taking out in the field with a built-in battery.
Yeah, and I'll add to that. If the first thing you're doing is low power in the field, you don't know what you're missing by going down to 5 watts. When you go home and you get your 100 watts on the tower or something, then you recognize it. There is a question here. I have eye problems. What is a good choice for HF for me?
Well, I don't have the experience to be able to answer that question necessarily. It depends on the particular eye problems. But remember, if you're using a computer interface with your radio, that allows you to make the display from the computer interface larger. So I know that some people have used, for example, the Yaesu FT8 18 and 817 have very small displays on them. So people have used the computer interface to be able to view it much easier.
Yeah, maybe a screen reader or something.
Yes.
If you use an interface might help too.
But I'm sorry, I'm not the best person for advice in that particular area.
Yeah, that's a tough one. I'm not sure where to recommend him to go. I don't know if OGG later on in our next presentation may have something to answer on that one. But anybody in house here ask a question? All right, we got another
question. So I was just wondering about tips, tricks for dipole antennas. Like what size, or I realize it depends on the frequency, but any tips or tricks for that?
Portable or home installation?
Home installation.
Home installation. Try and get it up as high as possible. If you have 2 supports, that's a great way to go. But if you only have 1 support, you might consider an inverted V. If you want a multi-band dipole, consider feeding it with ladder line as opposed to coax and using an antenna tuner, and you can have, it's not truly a dipole at that point in time, but you can increase the bands available to you. A traditionally designed dipole does not have full multi-band capability when it's fed with coax. But take a look at some of the extended ZEPs and some of the other twin-fed or wire-fed antennas that you can use with an antenna tuner.
Yeah, and if you have a specific band or something that,
Yeah, if you have one specific band, a resonant dipole is a very inexpensive way to get good performance. You could feed it with traditional coax, cut it to the right frequency lengths, get it up high, and you'll be surprised at the performance. Now remember, the performance of a dipole is very much dependent on the height, but the height is also very dependent on the frequency. The lower in frequency you go, for example, 160, the antenna has to be much higher to be effective. Whereas on 20 meters, it does not have to be as high as it does on 40 and so forth. So the height of the dipole is very important. You'll read some stuff about NVIS antennas where people say get it down close to the ground. The real truth is, in most cases, in home installations, people don't have it up high enough to worry about not being able to get near vertical incident performance also. So dipole, get it up as high as possible. Either use a well-tuned dipole for one band, or if you want to use a multiple dipole, think about some of the other options, such as feeding it with open line.
Yeah, and what he refers to there, that NVIS, is you can get lower the lobes on the antenna rather than having a nice angle going out, tend to balloon up vertically, so you get reflections straight up down off the ionosphere, and it's kind of iffy and local would be the case. So that's what NVIS is about.
And if you can't get two antenna supports to get your dipole up high, think about getting one good high support and doing an inverted V.
I can vouch for that on 180, on 160 and 80. That's what I have. It happens to be up about 80 feet, but just the inverted V works awesome into Europe and wherever. So another question here.
Will be just 1 second. That end-fed antenna that David was talking about during the ARRL presentation this morning, available from the league for about $50. That's a good way to go too if you only have one support and you can get one support up high.
Doesn't change any of the band allocations per se. So where sideband is where sideband is.
Bruce. Okay. Next question.
When you're setting up an antenna, how carefully do you have to make sure that it's isolated from like trees or vegetation or things like that? If there's branches that touch it or anything else, is that going to cause a problem, or does it have to be completely isolated?
The answer is it's not as exact a science as you would think. You want to avoid being, first of all, you never want to be near any kind of wire or any kind of electrical thing or any support pole for electrical. So that's a definite. Don't even think about putting an antenna up close to it. But for non-electrical devices such as trees, bushes, etc., it's best if you avoid contact. But sometimes it's inevitable that you don't, that you can't. So I wouldn't let it worry you too much. But try and make sure that your initial installation doesn't have that possibility. But today we had some ice on the trees and everything was sagging down a little bit. And I saw that there were some lines touching my sloper. Some tree branches touching my sloper that normally don't, and it was still performing okay. But you don't want to design it that way because you're only looking at future problems.
Yes, and if you go across branches, if you're going across them, right, like a T, then you get less coupling there. But the other pieces you have, at the ends of a dipole, it's a very high voltage area, so that would be a place where you might create a problem. High current nodes in the antenna aren't so important, but that's one thing to consider. So the very end could be a place you don't want to put it, like in the middle of a pine tree that might catch fire when you're doing 1500 watts or something. That could be a problem, but as far as performance, not a big deal.
One of the questions I often get is, what is the best antenna to put up? And I can tell you, I instead have the list of the worst antennas you can put up. So my 5 worst antennas, the worst one is no antenna at all. The second one is an antenna that's still in the box, not assembled and not put up. The third one is an antenna that's put up, but put up with poor coax line or poor installation. So those first 3 are definitely the worst antennas. But most people, as they get started in amateur radio, you're going to find out that one antenna might not be all you want. You might want multiple antennas for different purposes. Especially, no question, I'm not even talking about the difference you're going to need for HF versus VHF. Definitely 2 different antennas. But even for the different HF bands, I'm operating my different HF bands. My 40 meters is pretty much on my vertical My 80 and 160 are on my slopers, and the rest of my HF bands are on my tower on my beam. So again, one antenna may not be your final solution.
Okay, and with that, we're gonna have to call it quits. I will make one comment on the. Oh, never mind. I forgot what it was. So I was gonna
Well, just one quick reminder: tiny.cc/K8ZT-P will get you access to all my presentations. And if you have a local club that you're a member of and you'd like a talk for your local club, I'd love to do a presentation for you all via Zoom. So just K8ZT@AWRL, send me an email. I'd be happy to schedule a time and do a presentation, especially if you're in one of the states I still need to complete my Present All States award. So.
K8ZT, Anthony, thank you so much.
You're welcome.
For your generous support of the hobby here. We really appreciate it. I remembered what it was, and in line with what he's talking about, having an antenna in a box and whatnot. My first antenna was my dog's run. So it's this aircraft cable that ran 150 feet in the backyard. I clipped an alligator lead onto it and hooked it up to my radio, tuned it, and that was my first antenna. Made a contact in Antarctica on it. I have to say I burned got RF burns running it. CW, it would like tickle my fingers because it wasn't well matched, but heck, it was an antenna, right? So anyway, thanks so much, Anthony.
How did you do with the dog?
Well, that's my auto tuner, right? So as the dog went up and down, it would change the tune of the antenna.
Worked all dogs.
Worked all dogs. All righty. Thanks so much, Anthony.
Okay.